Letterkenny IT. In this set of slides, we're going to take a look at Z-scores and understand what they are. We'll also take a look at and understand what is normal distribution. Again, the term is often used when you're reading articles, etc. And what does it actually mean? Again, be familiar with the term skewness. Understand what sample sizes are and how they affect your results, and also their effect on standard deviation. Be familiar with what margin of error is, and also be able to take a look at box plots. And these are some bits and pieces that we find that students often aren't familiar with. Okay, so a standard score, it's a measure of relative position, not what the data is, but how far it is from the mean. Okay, so how far is the piece of information you're looking at from the actual mean? How unusual is that particular score or particular result from the mean? There are two main types of standard scores. There are Z-scores, which we will take a close look at, and again, just be familiar, T-scores are very similar, slightly different, but they're in the same category. They're types of standard scores. I'll explain what they mean. Okay, hit pause now and take a look at this video. If you just click the heading up at the top up here, then you should be able to see this video. Just a quick refresher on what standard deviations are and exactly what that means. Okay, taking a look at Z-scores. It's a statistic expressing how far a particular result or score is from the mean. But in terms of standard deviations, how many standard deviations is the piece of information you're looking at from the mean? How far away from the mean is it? This is a standardized score, which makes the Z-scores are standard across different groups or sets of data. Okay, which means that you can compare one Z-score with another Z-score from one experiment or one piece of research to another piece of research. And that's why Z-scores are particularly used in statistics. Exactly what Z-scores are. So hit pause, and if you click on this link down here, it'll show you the video. And when you're ready, resume. Okay, so looking at this, the normal or distribution, and you can see we've got 0 here in the center. It's the values of Z going to plus and minus 3. So a standard or normal distribution has a bell-shaped curve. We saw that in the video. It looks like the shape of a bell, and has a mean of 0 and a standard deviation of 1. Okay, and again, here's another video that I'd like you to watch down here. If you click on this link down here, it explains again exactly what the normal standard distribution is, and it's quite a good video to bring you up to speed. Okay, so to review, you've got the mean in the center of a normal distribution. Cases are distributed symmetrically, okay? So it has to be symmetrical. If you folded it down the middle, this side would also match this side, okay? The extent of the spread of the data around the mean is measured by the standard deviation measured in standard scores, okay? So measured in Z-scores. Area beyond 2 standard deviations above the mean is this area up here. Okay, characteristics then of the normal curve. Bell-shaped, fading at the tails. In other words, more values are in the middle and odd, or there's fewer odd or unusual values in the tails. 100% of the data fits on the curve, with 50% before the mean and 50% after. In other words, it's symmetrical. The distance from the mean is measured in Z-scores. Okay, now 68%. This for standard distributions, 68% of the data falls within plus or minus 1 standard deviation of the mean. 95% of the data falls between -2 and -3 standard deviations of the mean, And 99.7, practically everything of the data falls between -3 and +3 standard deviations of the mean. Displayed graphically for you. Okay, we've got the mean here, which is at 0, and this is about 68% of the data falls within ±1 standard deviation. So 1 standard deviation from the mean, either positively or negatively. Okay, 68% of the data falls here, and we said within, that's 2 standard deviations that way, or 2 standard deviations that way. And we have 95% of the data falls that way. And out here in the tail bit, 3 standard deviations, 1, 2, 3 that way, or 1, 2, 3 standard deviations, about 99.7 of the data falls into that area. Okay, so this is a skewed distribution. Okay, immediately you can say it's not bell-shaped, it's not symmetrical. Okay, and you can tell that it's a skewed distribution. It is not a normal or a standard distribution. Okay, the mean is not in the middle. Okay, the median, where 50% of the results will fall that way, or 50% of the results will fall that way, again, it's not. Okay, so non-normal distributions or skewed distributions, a non-bell-shaped distribution of scores where the mean and the median and the mode, this is negatively skewed. Okay, the mean is less than the median and the median is less than the mode, or the most commonly occurring data item. Okay, this is a negatively skewed distribution. Okay, where the mean is greater than the median and the median is greater than the mode, this is a positively skewed distribution. Okay, so here we've got a picture graphically of a positively skewed median. And we have our mean here. So if the extreme scores at the upper or higher distribution, it tends to be positively skewed. And the mean, the median and mode of this particular data item here. Let's just do a little quick bit of revision here. Okay. So the mean, you add up all the data items and you divide by the number of data items. Okay, so add them all up and divide by the number of data items. The median, you put them in order and find the middle value. The mode was the most commonly occurring item. So the only thing that repeats is the 20 in here. Okay, and we can do the same for bus A and bus B. Okay, here it is from the mean, the median. Okay, we've put them in order. The median is 0, the middle value is 0, and the mode is 0. For bus B, okay, the mean, add them all up, is 95. Divide by 5 items, the mean is 19.8. The median, we have them, when you line them all up, the median is 20, and the mode, both 19 and 20 repeat. Okay, bus A is positively skewed. The mean is greater than the median, and the mean is greater than the mode. Okay, bus B then. Okay, and bus C. Negatively skewed then. If the extreme scores are on the left-hand side, it's said to be negatively skewed, and you've got your mean here. It's really important to know whether data follows or a variable follows a normal distribution, because it assumes, when you're doing statistical tests, it assumes that your data is normal. If your data is not normal, then you cannot perform those tests on it a lot of the time. So it's really important to know whether your data is normal or not. Statistic packages normally test this for you. You don't normally have to calculate it out. But it's a very, very important thing, and a lot of learners overlook this particular step. Okay, the distribution is unlikely to be normal if the mean is very different from the median, or 2 standard deviations below the mean give an impossible answer. So for example, the height is less than 0. That can't be. Okay, so it's another way of checking to see if your distribution is. Moving on to box plots. So it's another way of representing data. It's often used in statistics, but it's not something that you might come across in newspapers or sort of magazines or the television as much, but you will read it or see it in some of the journal articles that you'll be reading when you're in college. Okay, so here's a box plot here. The oldest person in kilobags is close to 90 and the youngest person is close to 15. Okay, so here is the youngest person, okay? Here is the oldest person, okay? So you can see the minimum and the maximum, okay? The median age of the residents is here, so that's the median, okay? And that's 44. The lower quartile, or the 25th percentile here, okay, is about 25, and the upper quartile is here, okay? So we've got the 25%, the 50%, the 75%. We've got our minimum and our maximum, okay? And the upper quartile is 67% here. Okay, so reading a box and whisker plot or chart. Let's say we ask 2,852 people how many hamburgers they've consumed in the last week. We'll sort those responses from least to greatest, and then we'll graph them with a box and whisker chart or plot. Okay, so we take the top 50% of the group, 1,426, which is half of the 2,852, who ate more hamburgers than the rest of the group. They're represented by everything above the median, or the white line on the chart that we'll look at on the next slide. Those in the top 25% of the hamburger eating, which is 713 people, are shown in the little whisker or the single line that goes above. So sometimes dots are used, and dots represent those who ate a lot more than normal or a lot less than normal. They're sort of outliers. And in our chart that we're going to show on the next page, we don't have them, but sometimes you will see dots there, and they're just pointing out to you that these pieces of information were outliers. If more than one outlier outlier ate the same number of hamburgers, dots are often placed side by side. And we won't actually go through that, but sometimes if you ever see those dots, they're just showing you that they were unusual pieces of information. Okay, so here is our medium here. Okay, we're looking hamburgers consumed. Okay, we've got female and we've got male. Okay, and so the white line is showing you the median, or the 50th percentile. This is the 75th centile, and here is the 25th. Okay, and here likewise for female, that's the 75th, and that was the 25th down here. And sometimes they put a little straight line across here, and that's showing you the 97.55 centile and the 2.5 centile as well. In here is your interquartile range, okay, which is showing you from 25 to 75, and samples. The population. This is the complete set of individuals, objects, or scores of interest. So, for example, if you wanted to find out what the population of Ireland felt about a particular topic, that would mean asking every single person in Ireland from age 0 up to 120 what they felt about it. Often this is too large and it's too difficult to do in its entirety. Okay. Now, the population of a particular class, that's every member of the class, that's a much smaller population, and it might be practical to ask the full population in a smaller group like that. Okay, so a sample then is a subset of a population. A sample may be classified as random. Each member has equal chance of being selected from a population, or convenience. Okay, so for example, if you were trying to find out what people in Ireland felt about a particular topic, and you decided to ask just people in Donegal because they're very close and it was easy to ask them, that would be a convenience sample. But if For example, you spread it out equally among all the counties, between male and female, between young and old, etc. This would be a random sample. Random selection attempts to ensure the sample is representative of the population. Okay, so for example, if you asked that group what do they feel about Donegal getting 50% of the budget for the road network, if you only ask people in Donegal, there's a fair chance that they would think that was a good idea. If you asked people equally from all the counties of Ireland, I'm not so sure they'd be happy for Donegal to get most of the budget. So a random selection attempts to ensure that it's representative of the total population. When designing a study, the sample size is an important consideration because the larger the sample size, the more data you have and the more precise your results will be, assuming that you've got high quality of data. So for example, you were trying to decide whether you should increase the amount of time spent in classes. If you only asked one person, then you might not get a very accurate response. If you asked 200 people, then the chances are that your results are going to be more accurate of what the whole population feels about the topic. If you know the level of precision you want, that is the desired margin of error, you can calculate the sample size needed to achieve it. Let's talk about that. So margin of error. The statistical survey had a margin of error of plus or minus 3 percentage points. What does that mean? Often you'll see that written in some sort of words like that. So what actually does that mean? Most surveys are based on information collected from a sample of individuals and not the entire population as a census. So a census is the total population. And because it's not the total population, there will be a certain amount of error that is bound to occur because you're not asking everybody, you're only asking a sample. The margin of error is caused by sampling error, which is the error that occurs simply because the researchers aren't asking everybody. The margin of error is supposed to measure the maximum amount by which the sample results are expected to differ from those of the actual population. Okay, so the amount that the sample will be different from the whole population. Because the results of most survey questions can be reported in terms of percentages, the margin of error most often appears as a percentage. This margin of error in action. Okay, we're looking at two pubs. Suppose you know that 51% of people sampled say that they plan to vote for Gallagher's Bar in an upcoming vote on Pub of the Year. Okay, now projecting these results to the whole voting population, you would have to add or subtract the margin of error and give a range of possible results in order to have sufficient confidence that you're bridging the gap between your sample and the population. So 51% of the people, you're very close. You know, it's not like you're 95% of the people said they were going to vote for Gallagher's. So there's only two pubs in this competition. So the other pub is very close to you. And if the margin of error is high, then maybe Gallagher's Bar won't actually. Okay, following on from that previous point, supposing the margin of error is plus or minus 3 percentage points, you would be pretty confident that between 48%, which is 51 minus 3, and 54%, 51 plus 3, of the population will vote for Gallagher's Bar. Now, if only 48% of the people vote for you, you don't win. If 54% of the people vote for you, then you will win. So this margin of error shows you the range of possible answers. So we think it's going to be 51, but it could be as low as 48, or it might be as high as 54% of the votes will come your way. So it's very important to know the margin of error. So in this case, Gallagher's Bar might get slightly more or slightly less than the majority of votes and could either win or lose the Pub of the Year prize. Okay, standard deviation and sample size. It's important to know, as sample size increases, so the standard deviation decreases, okay? So the more people you ask, as long as the sample is representative, then the lower the standard deviation, the more accurate your results are. So if you only asked 5 people, then your results of the survey might not be very accurate. If you asked 5,000 people, then your results are way more likely to be accurate. So as sample size increases, so the standard deviation decreases. Okay, and this is where your sample size is very small. Okay, the number of people you asked is 10. This one here is the number of people asked is 50, and here the number of people asked is 150. And you can see the bell-shaped curve is getting higher and higher, and the size of the standard deviations is getting smaller, and that's why it's a tighter curve. An outlier is an observation that does not appear to belong with the other data. Okay, so for example, if you were asking people how many siblings did they have, brothers and sisters did they have, and most people were saying 1, 2, 3, 4, 6, 3, 1, 7, and one person said 58. Gosh, that's an unusual piece of information. Okay, that's an outlier, an observation that does not appear to belong with the other data. Okay, outliers can arise because of a measurement or recording error. Actually, somebody wrote down 58. They meant to write down 5 and 8 as opposed to 58. Okay, so it could be that, or it could actually be real. Okay, so you have to look closely at outliers. An outlier might be indicative of a subpopulation. Abnormally low or abnormally high value in a medical test could indicate the presence of an illness within the patient. So you have to look very closely at outliers and work out, is it some problem with the way that you're recording things, or is it some other type of statistic that you need to look carefully at?